Hi everyone and welcome back. This is the second part of the tutorial, which aims to create a third-person controller in Godot 4. In the previous part, we showed how to import an animated 3D model into the project and prepared a simple scene in which everything will take place. Now, let's move on to the actual implementation of the third-person controller. Okay, let's proceed. We switch to the main scene and let's try to run our game. And of course, we won't see anything because, yes, right, in the editor, Godot automatically adds a default directional light 3D and camera, but we don't have it in runtime. So let's add it to the main scene. Right click and select. Let's start with the light, directional light 3D, and put it a little bit up. So Y would be 10 meters. Yeah, okay. And let's rotate it a little. Minus 45 and 45. Okay. Yeah, let's work with this. All right, and now the camera. But we won't have a static camera because after we add the script to move our character, we want the camera to follow it and react to all change of direction, rotations and other things. So instead of adding a simple camera, we will start with a node 3D that we'll call camera controller. And as a child node, let's add spring arm 3D, which is a very handy node that will allow the camera to follow the character, but to do it in a bit of a flexible way. So for example, we can change the length of the spring arm to avoid walls or other obstacles, and just to make it as you are used to see in the many 3D games. So spring arm 3D, and as a child node we will have the camera 3D. Very well. And we definitely don't want to observe the floor, so let's put the camera controller up and behind the character, maybe a bit more, and maybe rotate it a little. All right. And the other thing we need in this scene is another node 3D that we will call look at, and this will simply tell our camera where to point its focus, because this point can change and we will handle it from the code. And no, I think it must move with camera as well, so we'll make it a child of camera controller. That's correct. And move it here in front of the character. Let's save. And now if we run again, yeah, we can see something. We cannot do anything, the controller is not implemented yet, but definitely the scene is working. Now I switch to character scene and we'll add something to the animation tree. Right click and animation, and let's start with idle, which is our definitely basic animation to use, and we want to connect it to the start. Let's switch to this arrow and drag, and now the model automatically changed to the idle animation and it's animating. If we start the game again, we should see it in the live scene. Yes, the character is standing and looking just over there. Very well, so let's add the script. The character, add a new script, and since the class is character body 3D, Godot automatically offers us a template for basic movement, and we will gladly use it. Let's create, and we can see a lot of code has been generated for us. but we will start improving it from the start. For example, we have an animation for walk and for run, which means the speed must be different for these two states. Let's change speed to walk speed and set it to 2.0, and another constant would be run speed. That would be 6.0. All right. Now we need to indicate if we are walking or running, so let's add a simple flag, running, and the default value is false. Okay. And to activate the running state, we will hold the shift key. So to do that, we must handle the input. But first, let's map the shift key to a new action in project settings, input map. Let's add a move run and click plus and press shift key to map it. Okay. And now we can add the function input, which has event as a parameter, and we'll use a ternary operator, which means running is true if input is action pressed, not just pressed, but pressed, because we want to press it continuously, and once the shift is released, we will get back to walking. Move run, our new action, else false. So if the action is pressed, running will be set to true, otherwise it will be set to false. And one last thing, it's definitely handy to allow the player to finish the unfinished game on pressing the escape key, especially when we decide to capture the mouse, and it would be pretty complicated to leave the game in the full screen mode. So if input is action, now we need just pressed, because this is definitely pressed just once. And let's use the default UI cancel, which is mapped to escape key. Let's leave the game, get 3, quit, quit here. Great. Alright, now we need to fix the physics process, because it's using the constant we already deleted. So first we'll define the speed here. Var speed is run speed if once more, run speed if we are running, or walk speed. Okay, and we'll replace all speed in uppercase with speed in lowercase. Very well. So what happens when we start the game and use arrow keys? Yeah, it's moving. It's not animating, but we didn't expect that, and if we hold shift, it's moving faster. Perfect. That's what we wanted. And I pressed escape and the game finished. Okay, let's implement the animation tree in the code, but first we must define it, because as you can see, it's pretty empty right now. Let's add animation for walk and run. I will right click here and add animation. We'll start with walk, because this is usually what we get from the idle status, and switch to the arrow. Let's drag one arrow from idle to walk and another one from walk to idle, because when we stop walking, we definitely want to change it. You can see that it is flashing quite rapidly, because it's changing on every frame. We didn't define the conditions yet. Let's click the arrow, switch to this and click to arrow, and now we have to add condition. We will call it walk. So when walk is set, and only then when walk is set, we will transfer from idle to walk, and vice versa. when we are in the walk status, we want to set idle in the code and return to walk. And we'll do the same for the run animation. Right click, run, and again 2 arrows, walk, run, run, walk. Click the first arrow, the condition, we will call it run, and for the opposite direction we want walk. Very well, the basic tree should be ready. Let's switch to the code and implement it. So I'll start with adding a reference to the animation tree. I'll drag the node and hold the control key, so when I release the mouse we have the whole already declaration automatically generated. And now I'll get back to the end of the physics process function and implement the state transitions. So animation tree set. Let's start with the idle animation. So I will start typing, and the code completion already offers me all these conditions we created. So if we set the condition to idle, we want to do it only if input there is of course this kind is vector 2 0. Why is that? Input there is our input from the arrow keys, and once we remap it to WASD from these keys, and when no key is pressed, it returns a 0 vector, which means we don't do anything and the character should be in the idle status. Let's copy and paste for the other states. So walk, walk definitely not 0, we must be walking somewhere, and another condition is that we are not running. Not running. Very well. And running is very similar, but in this case we are running. All right. And of course we have to correct this condition, change it to run. Very well, let's start the game and do some moving. Yeah, it looks like the character is walking. It's not turning, but this is not implemented yet, so this is correct. And when I hold shift, it's running here and there. So yeah, animation tree is working. So before we fix the camera and the character rotation, let me just quickly implement the WASD keys so we can control our character in a more convenient way. So project settings, input map, and let's add move up, move left, move down, and move right. Okay, and now move up, plus, that's W, move left A, move down S, and move right is D. Okay, and now we will change these strings here. Move left, move right, move up, and move down. Let's try it out, and I'm using these new keys and it's working very well. Now I can do everything by my left hand, including the shift key. Much more convenient, especially after we implement the rotation using the mouse, rotation of the camera. By the way, you have surely noticed that the animations in its current status are pretty unnatural because they change instantly. For example, I press W and it starts moving in instant, and if I stop walking, it just stops. It would be nice to have some sort of blending, some smoother transition, but we can do it very easily. Let's select the animation tree again and click the transition arrow, and there is a crossfade time. Let's put it to, for example, 0.2 seconds. This would be pretty sufficient, I think, and let's do it for all these state changes. 0.5. And now when we start the game again and start walking, yeah, looks better. And if we stop walking, it just doesn't get to idle state instantly, but there is this short delay and animations are blending into the next state. So this is one of the ways how to achieve that. Okay, let's finally implement the camera that would follow the character. We'll do it in the main scene, and we'll add a new script to the camera controller. Let's create it and implement, of course. So I'll start with defining the reference to the player's character body 3D. Let's just call it a hero, and we will also need the look at hero parameter variable, which is simply the point where the camera would look and align with the current player's movement. Okay, to make it more flexible, we will define two export variables. Export var sensitivity, which will help us move the camera on the mouse movement and with the required sensitivity, and export var zoom sensitivity, because we will take advantage of the mouse wheel to change the length of the spring arm, which is used to attach the camera to the position behind the player. Very well, and now of course we need references to the mentioned nodes, so I will just drag with Control spring arm here and the camera. Okay, fine. Now in the function ready, we will assign the current hero object, because you know, in many games you can change the characters you are currently controlling. So this is the reason why I didn't attach the camera as a child node of the character scene. To be ready for multiple characters, we will just in this part of the code find the first available node that belongs to some group. Let's do it. Hero, let's get 3 and get first node in group. Let's call it playable. Not the best name, but let's work with that. And of course we need to add this character object in the node to the playable group so we can find it. And look at hero would be just a subnode of this hero that is called get node look at, because that's what we defined here in our character scene. Very well. Where is it? Here. Okay, let's save it, and again we will need to implement the input function, because there will be a lot of input from the mouse, mostly from the mouse. So func input event, and now if event is input event mouse motion, because we'll be moving the mouse to move the camera. Let's find the camera rotation based on this event. Camera rotation would be current rotation of this node and x coordinate minus event relative y. And of course we need to incorporate a sensitivity variable into that. But since the sensitivity would be probably very small and we don't want to have two big numbers in our inspector, let's just multiply it by 1000. Sensitivity. This is a result of my experiment, so just I use 1000, but you can use anything else, even make it a variable and set it in the inspector as well. Now we need to fix the rotation of this object and the white coordinate. That would be we subtract the event relative x and again divide it by the sensitivity. And now we can set the final camera rotation. But since we don't want to just rotate it anywhere 360 degrees, that wouldn't look good in our game, let's clamp it to some, let's apply some limits. So that would be a clamp, and we are clamping the camera rotation with the bounds minus 1.5 and minus 1.05. Again, this is the result of my previous coding, and it simply just assures that the camera wouldn't go, for example, if it's above the player, it just stays there and doesn't go further. And rotation X would be set to this camera rotation. All right, so this is the mouse movement, and now we want to implement the mouse wheel detection and change of the spring arm length. So if event is input event mouse button, because the wheel is a button as well, let's find if event button button index, I mean, is mouse button wheel up. In this case, spring arm 3D and its variable spring length would be decreased by the zoom sensitivity, and again we want to have some range there, so we'll clamp it again. This time we'll clamp F because we are working with floats. Spring arm 3D, spring length, and range would be no, sorry, I forgot to subtract the zoom sensitivity, and the range would be 1 and 6. Good. And let's do a similar thing for the wheel down. I'll just copy and paste to save time. So this elif is wheel down. This time we would be adding the sensitivity. Great. So that's all we need to do in the input function, and now in the process function. So because we are moving, we need to change the global position, and that would be vector 3. I keep forgetting adding the equals for some reason. Sorry. Vector 3. Now we take hero's global position. Global position, x coordinate, hero, global position, y coordinate, plus 1.8. Don't ask me how I found this constant, I don't remember, but it's again, it's probably a result of trial and error. And the hero global position z Very well. And now we want to camera, look at that. Look at hero, global position. So definitely not at, but at the current node in front of the hero's face. Global position. Okay, let's see what happens if we just start a game. Yeah, I move the mouse and the camera is moving. When I move the character, camera is moving along with that. I am using the mouse wheel and the spring arm is extending or shortening. Perfect. But there is one more thing. It's not changing the direction. It's not rotating. So we must implement this one last thing. Okay, so first of all, I already remember what is this constant about, because in fact I am putting the camera controller inside the hero's head, not behind him. So we are getting the hero's coordinate, and because his height is about 1.8 meters, this is the coordinates of the head or forehead or anything like that. So this is definitely correct. Okay, so the last thing, as I mentioned, we need to implement the rotation of the character, and for that we have to add the reference to the camera's look at node. Let's drag it here with control and we have it as look at, and because we have two nodes called look at, let's make sure we distinguish between them and call it camera. Look at camera. Okay, and now in the script, if we are moving, we will just do this and look at the following coordinates: vector 3 and camera look at global position X, now global position Y, and camera look at global position Z. That should be everything. Let's check it out. And yeah, moving and it's rotating along with the camera. Let's just try all states like walk, idle, walk, run, rotate, go, 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 mouse wheel, and jump from the edge, and we are falling because there is gravity. Very well. Wow, that would be 2 animations if we don't count the idle state. But what if we later decide that we want to add more animations and ideally share them with other 3D models in our game? We will solve this problem using the animation library, but not in this video because we have already approached the half-hour length again. We'll finish our mini-series in the 3rd part. See you soon.